ready for takeoff.
Good afternoon, everyone. My name is Gaurav Singh, and I'm an engineer at Pattern. So today we are going to talk about static typing in Ruby using RBS. So yeah. So first of all, what is this typing business? Like, what do we mean by types, right? So broadly, there are two categories of programming languages. One are which are strictly typed languages, and another is which are dynamically typed languages. So let's take the first example here of a Java code. So here, string variable, str variable has type string, right? Which contains the value hello. But if we try to assign it value as integer, we get the syntax error. While in the dynamically typed languages, type is associated with the value that variable is holding. So you can see over here in the second example for the Ruby code. So name type of the name variable is a string when it's holding the value who am I, and its value its type is integer when it's holding the value 5. So type in the dynamically typed language is associated with the value. Okay. So what is the problem with the dynamic typing? So let's consider the first example here, Java code. So we have a simple add function and which is accepting two arguments. Both of them are integer types and we are just returning their sum. Now, if I'm trying to pass those arguments with the string type, I'm going to get a syntax error, right? Now let's consider the second example of the Ruby code. Again, I'm passing two arguments and I'm going to sum them. But if I'm passing the argument string, it's not going to give me any error when I'm writing the code, but it's going to give me the error at the runtime. So these kind of issues which we face with the dynamic typing languages, like people would say we can add extensive test code, but we all know sometimes humans do make mistake. So to overcome these problems, static typing has been introduced. Uh, what Yeah. So advantages of type checking. So first thing, it's a proven fact into multiple languages like JavaScript and Python. There are very popular static type checking libraries. TypeScript is the very popular version of the JavaScript, and MyPy is a very popular package in Python. It eliminates a lot of errors like no method error, nil class errors at the runtime, better integration with IDs. Varun has just showed like how to integrate in the IDs. It provides documentation for the code. So like when we annotate our code with the static typing annotations, we get implicit documentation for our code at that point of time. So like type checking, what are type checking systems are there in Ruby? So this is not something new in the Ruby ecosystem. Like back in 2009, there was something called Diamondback Ruby or Druby. Then Tufts University came up with RDL, and then Stripe launched its Sorbet, and then in 2019, Ruby core team launched RBS. Now, what is RBS exactly? So the RBS stands for Ruby syntax. It is basically, it provides, you can define your Ruby code in RBS. Basically, you're trying to say how my Ruby code is going to look like. You can consider this something as type definition files of JavaScript .t.ts extension files, which we generally use. So it basically provides the structure. RBS does not check the type of the Ruby code. It only provides the programming interface to define the structure of your Ruby code. So what options does RBS comes up with? So there are a lot of options which RBS provides, which is basically for parsing the code, seeing what kind of AST it generates, how to annotate, list, probing the ancestors of the Ruby class. In the scope of this talk, we are mostly concerned about the kind of code which we are going to generate for our Ruby code. So we'll be focusing on the prototype option. So RBS prototype comes up with three options: RB, RBI, and runtime. So RB uses syntactical parsing of the Ruby code. RBI, so Sorbet is a popular library, and for Sorbet there are RBI files which are generated for Sorbet, and to convert those Sorbet RBI files into RBS, we use RBI. And then third option is runtime. So runtime is basically it loads your class into memory and then try to see what all functions, methods, and attributes are defined on top of that class or object, and then generate the RBS code for that object. So let's take a very simple example here. So we have a class user. It has two attributes, name and age, and we have just a constructor over there. Okay, so we are going to generate the RBS file using the RB option. So the output of this command will be something like the sig option you are seeing over here. So attribute reader name is untyped and age is untyped. And if you see the function sig for the function, so name of the function and then all the arguments which this function accepts and its return type. So over here, you will see all these attributes are untyped. Untyped basically means it can accept any type of value. But the basic idea of like having static typing is not to have untyped value. We need to have define some type of value which we want to accept for our attributes, right? So let's change it to like the kind of values we want for our attributes. So for example, for name, we want string, and for age, we want integer. So here we have defined, declared name as string, age as integer, and initialize accepts two parameters. One is string, another is integer, and returns nothing. Okay, so let's take the example over here. So what I have done is that I have tried to instantiate this user class with with two arguments, and both of them are string, right? So and if you see on the previous slide, we have one string and one integer, right? So this is going to give me error. First, so error says like string type is not accepted because argument type is integer. So these kind of errors we can catch very early when we are trying to annotate our code with RBS. Okay, so let's see what happens with the dynamic attributes. So here we have a code in which we are dynamically define getters and setter for attributes name, age, and gender. So if I'm going to use RB option, it only does the syntactic parsing of the Ruby code. So it's not able to identify what all methods are there into the class. So it only says, okay, this attribute is there, which is of the array type of name, age, and sex, right? So to overcome this problem, we can use runtime option, which we had discussed earlier. So what runtime will do is that we'll give it the path of the code where that class is defined, and then what class do we want to generate RBS code for. Okay, so and once we do the runtime, run the command, we'll see that it has loaded the class into the memory, and then it has seen the age as method, then age, like you can set the value for the age as the method, gender, and setting the value for the gender. Okay, so now let's see a bit more detail into for different kind of functions, what kind of RBS SIGs we can write. So let's take the first example over here. So in this example, we have a method called greet, and this is going to accept as an optional argument for the class method. Okay, so for the optional arguments, anything which can be nullable, we are going to use question mark to define that this value can be nil. So if you see at the line number 11, the function greet is accepting an argument with a string type which can be nil. So we can like call the greet function without any argument also. But if you're going to call greet, then it should be string only. There is no other option. Let's take another example where like our function can have a variable number of arguments. So here we have example class which have function name ends with, and it accepts like name argument is fixed, and then we are going to have variable number of arguments using split operator. So if you see at the line number 13 over here, so the first argument is fixed, like you have to, whenever you are going to call this function, you have to provide the name. But using the split operator again, it's going to accept the variable number of arguments over here. And in this case, the return type is Boolean, because the function is checking whether the name ends with particular value or not. Okay, so let's take another example. So we have a class called example, then it has a function multiply. And it is going to accept two arguments. First is arg and another is multiplier, right? If you see the shell code over here, so we can call this multiply function with string as well as integer or float values also, right? So if I'm going to call it with string, then the default value of the multiplier is 5. It's going to print Ruby 5 times, that string 5 times. So in this case, I have provided argument as Ruby, and then it is printing Ruby 5 times. And if I'm going to give argument as integer at the line number 13, if you'll see, so it's going to return the value as 20. So this function can return string as well as integer, both kind of values. So to handle these kind of cases, RBS has introduced union type. So if you see the signature for this particular function at the line number 19, so first argument arg, it can be either string or it can be either integer, and then we have optional attribute of integer, which is the multiplier. And the return type, if you'll see, it is again can be either string or integer type. Okay, so another example is with the keyword arguments. So you can see over here in the output, if I'm going to give a string and I'm not going to the second argument, if I'm not going to provide the second argument, it's only going to give me the first character of that string. And if I'm going to give the range of that string, suppose like range 4, then the first 4 characters of that particular string is going to be returned as an array. Okay, so for these kind of functions, if you'll see, the first argument is a string, then we have our range as named parameter over here, and you see the question mark which denotes that this is an optional parameter. And the return type over here is like you can have either a string or array of a string as the return type for this, this function. Okay, so now the duck typing. So like what happens when we have our objects or class where the duck typing is introduced. So let's look at this class over here. So we have this class car, which has like dynamic methods, wheels, engine, and roof. And then we are like setting, like creating getters and setter for these methods over here, right? Now, if I'm going to generate the RBS code for this using the syntactical parsing method, using the RB, so it's only going to generate the attributes. It's not going to give me all the methods which are there in the car class, right? And car is inheriting from my car. So if you see over here, if I'm going to call wheels on my car object, it's saying that my car does not have method wheels, right? But if you see the code over here, my car is inheriting from the car. So it should have that method wheels. The reason it's not able to identify why this method is not there is because RBS code does not have that method into the RBS signatures. So, so there can be scenarios when we cannot have RBS code which is like defined properly for a module or for a particular class which we are going to use. So to handle these cases, concept of interfaces has been introduced. So you can say like I have an interface which is like behaves like a car, and then it has all these methods, wheels, engine, and roof. And when you include that method into your RBS code, then you can call these like method wheels, engine, and roof on your object. So it's not going to give us error after that. Okay, So now comes the steep. So all the errors, type checking errors which we had seen earlier, they were generated using steep. So steep is the tool which actually does the type checking. So what happens is that RBS only provides us the syntax. It does not provide some mechanism to check whether the Ruby code, corresponding Ruby code is correct with the RBS code or not. We can only generate the prototype using RBS. Steep takes input of the Ruby code and the RBS signatures and then sees like whether the code is correct over there or not. So the way we can set up RBS, similarly we can set up Steep also. We just have to do Steep init and it will create a Steep file into our project. So basically we have to configure Steep, then we have to define like where our signatures are going to reside. So here in this case, they're going to reside in the SIG folder. What folder does it have to check? So if you see that it's going to check in the lib folder, the directory name where it's going to check things. And if we have, suppose, some files which we doesn't have generated RBS code for them, then we can ignore them. And we have to tell, if you're using some standard library or some gem from the outside, then we have to tell Steve that load RBS for these libraries also. Steep comes with stats option also. So here what I have done is that I have checked out Discord RB, did some annotation on top of that, and then try to see like what is the stats for all those annotations over here, right? So you can see like there are some files which are like 100% covered. For some files, their coverage is like in the 50s or 40s, depending on like how much detail I have like provided for those files, right? So Steep comes with these options also. And if we have to check like whether everything in our code has gone, in our annotation has gone fine or not, then we can just call Steep check and it will parse all the code and say, okay, things are good or bad, whatever, depending on it. So this I have run on Discord RB and I ignored like lots of files because annotating all of them was not practically possible at that point of time. But you can see like as the end result, there are not many errors. Okay, so now comes the sorbet. So the primary difference between Steep and the sorbet is that for the RBS, we have to like put the SIG files into a different file, while sorbet is an annotation-based system. So if you see that for the class people, for every function we have provided the annotation like SIG void for the constructor, and for the add function we have SIG in which it's going to accept the params as a person, and then it's going to return array of persons. So let's just compare the RBS code and the sorbet code just for the sake of like what is the difference or what are the similarities over here. So if you see over here for the add function, so the basic gist of these signatures are same. The add function on the left-hand side is the RBS code. So you'll see it's accepting the person object and returning an array of persons. On the right-hand side, you will see, so one difference in sorbet is that all the function calls, in the SIG, we have to define them as hashes. So when we are saying params, then we have to provide person. Person is our argument name, and then type of that argument. And then it returns array of persons. Second is this remove function. So remove function will accept person object and return, depending on if that person is there in the list or not, it's going to return person object, which it has deleted from the list. So you can see over here the question mark there in the RBS code, which tells like we might return nil also. And on the sorbet code, you will see that there is concept of nilable class. So the idea over here is that if it's going to return something, then it will return the person object. But if it does not, then it can be nil also. Same concept as in the search function also. So it's going to accept a string over here and might or might not return a person object. Right. Now we can use this in our CI/CD pipeline, and Sorbet comes up with RubyConf gem also, RubyConf Sorbet. So we might not necessarily have to like use it in our Jenkins or in our GitHub CI/CD. While for the RBS, we have to like add additional check in our CI/CD for like doing the type checkings. There are few things which are still not supported in the RBS code. It's in active development right now, so these things are expected. One thing which I feel is that there are multiple options to generate the output in the RBS, like RBI, RB, and the runtime. So there should be a tool using which we can compare the output of syntactical parsing and the runtime code generation and see which one has the better resemblance to our code. Then there are some useful gems we can use for like generating the code for our annotations, sort, parlor, and sorbet rails, RBS rails, and pronto sorbet. Yep, that's it. Thank you.